Hey, what's going on, guys? My name is Ivan Yosifov, and in this tutorial I'll be showing you how to create a simple puzzle game using Python and Pygame. So here's a preview of what we'll be doing. This is the puzzle game, and in the beginning we'll have this starting screen where we can choose the difficulty of the game. So if I press E, I get this image that is sliced up and the different pieces are scattered around. So what we need to do is when we click on a piece, it gets highlighted in this red border, and if I click another piece, they will swap places. So I can swap these images and solve the puzzle. So when we solve the puzzle, the whole image will appear, and then if I press spacebar, I can play again and I can choose another difficulty. For example, M is for medium, and here we have 4 rows by 4 columns. So again I can start making the image. And of course it gets harder right now because we've got more pieces. And if I choose the hard mode, which is 25 pieces, we can again start solving the puzzle. Okay, so this is what we'll be doing in this tutorial. As you see, there are no animations here. We're just using the mouse to swap pieces of the image. And I'll show you how we can slice up an image into different pieces. And the good thing about this is that this game is dynamic in nature. So if you want to make it 6x6 or 7x7, or even, for example, 5x10 or 14x23, you can still do it. It's all dynamically done underneath. Also, you can change the image if you'd like to. Okay, so this is the game that we'll be doing. So let's go ahead and get started. First of all, create a folder where I will be placing all the stuff, and we won't have a lot of things to do here. We just need one file for the program. This is where we'll be writing the logic, and also we'll need two assets. We'll need a font, and I'll be using this Hello Avocado font, and I'll extract it here. And also I'll be using this image of the elephant, where you can download it from this address, and these links, the font and the image, will be in the description. So I'll download this version. And I'll just call it elephant. Okay, now this image is a little bit too big, so I'll just quickly scale it. So I'll make it 880 by 600. Now if you see, it's it's 880 by 600. So this is all we need to do here inside of this folder. and I'm gonna open this file, the GamePy file, inside of the Mu editor. You can use a editor by your choice, but I like using Mu because it's very simple, and I believe it's perfect for beginners. It doesn't have a lot of options. Now, one thing to bear in mind is that because we'll be using the Pygame module, we need to import it. So here in the bottom right side of the editor, we have this cogwheel, and when you click it, we get these third-party packages, and we need to import Pygame, and all you need to do here is just write Pygame and click OK, and it will download the package if it doesn't have it, and you're ready to go pretty much. If you do not have Pygame, you need to install it using pip install. So in CMD you write pip install Pygame, and this will make it globally available no matter what kind of editor you're using. Okay, so that's done. Now let's go ahead and get started. So first of all, I need to import Pygame. We'll also be using with the random module, which is part of Python, so I'll also import it here. We'll use random to randomly place the images around the screen. We also need to initialize the Pygame module. And in the very end, we want to quit it when we finish the game. So between these two lines, we'll be writing the logic of the program. And we're going to start by creating the dimensions of the screen. So we want the screen to be 880 by 600. We also want to set the caption of the game window. And I'll just call it puzzle game. Now, whenever we're creating Pygame programs, we need to start the game loop. The game loop will be run a specific number of times per second. So in order to write the game loop, we usually set a variable, Boolean variable, and set it equal to true. Now this is an infinite loop right now, and in order to stop this loop, we need to write a little bit of logic. And in this logic, we need to listen for all the events that are happening inside of the program, and when we get the quit event, we want to quit the loop, and when we quit the loop, we go to this command that will stop the program. So inside of the while loop, we're going to create a for loop where we'll be listening for all events that happen inside of the game window, and if the type of the event type is equal to Pygame quit, we will set running equals to false. So when we quit the game window, we set the running equals to false. This will exit the while loop, and then it will reach this command that will end the game. So if you run right now the game. Oh, wait a minute, I need to save this one. Okay. So I forgot to open this game, this file here. So I'll go to desktop, game, and I'll call it game.py. Now when I run the game, you see here's the caption, and this Pygame quit event refers to this X that closes the game window. This pretty much exits the while loop, and that will close the program. And there we have it. It's working and everything is fine. Now a small thing I want to add here to the game, because right now that while loop will be run a specific number of times per second, and it depends on the computer. If you have a fast computer, this will be called multiple times. If you have a not so fast computer, it will be called less times. But because we don't have any animations, we don't have sprites moving on the screen, we'll just be clicking parts of images, so that's all the game is doing. I don't want this thing to be called a lot of times, so I will set a frames per second variable, and I'll give it the value of 10. So I pretty much want this game loop to be run 10 times per second, which if it was an animation would be very low, but since we're not having any animations, I want to go easy on the computer. I don't want it to be working too much because there isn't much happening in the game. Then we need to create a clock variable that will be taking care of the frames per second. And inside of the game loop, we'll be ticking the clock, and we'll pass the FPS variable. So this tells the while loop, hey, run me 10 times per second, not more. So a high-end computer will run it 10 times per second. Slow computer will also run it 10 times per second. Okay, and let me just run it to see that there are no mistakes. Okay, everything is good. Now I wanna define a couple of colors that I'll be using inside of the game. In Pygame we define colors using a tuple with 3 values inside of it. The first one is the red channel, the second one is the green channel, and the third one is the blue channel. So we have white, we have black, we'll have red, we'll have crimson, I believe it was 2020, 2060, and we'll have also orange. And right now by default the screen is filled with black, but I want to fill it with white. So I'll give this command screen fill and pass the color, and you see it's still black. And the reason why it's still black is that yes, we added here, but in order to make changes to the game screen, we need to update the game screen every time the while loop is running. So all we have to do is just give this command pygame display update. So every time things are happening inside of the while loop, it will update the screen. So now we see it's filled with white, and this is what I want to have. Okay, let's see now. Let me actually load the main image. So I want this elephant image to load it inside of the program, and I'll call that image BG for background. Now when I load the image, I want to add a rectangle around the image so that I can better position it and manipulate it. Now this function getRect adds a, I don't know how to explain it, but it adds a virtual rectangle around the image. So around this elephant, it adds a like a border around it, and I can refer to these borders, for example, using center or top left or top right, or just left for the left side or bottom for the bottom side. And it's very, very convenient when I have a rectangle around an image. So let me actually show the image on the screen. And we use again the screen variable. And when we show images on the screen, we use the blit function. And the blit function accepts two parameters: the image that we loaded, and the second one is the position of the image. And I already have the rectangle, so I need to give it a position. So I can say the rectangle of this image, let its top left coordinates be 0, 0. This is the x and this is the y. So I can so this rectangle right now have a position top left, that is 0, 0, and I can pass the rectangle as a second parameter to the blit function, so bgrect. And when I run the program, you see the elephant appears on the screen. And this first coordinate is the x coordinate. So if I give it 100 and run it, the x starts from here and it will move 100 pixels and then start showing the image. And I can do the same thing for y. For example, I can move it, for example, 300 from the top. So it's 100 from the left, this is the x coordinate, and 300 from the top, this is the y coordinate. Okay, this is all great and wonderful. Actually, let me just make them 0, 0. This is great, but how can I show a part of the image? Because right now screen blit will show the whole image. It accepts the image, the position of the image, and that's it. But I don't want the whole image, I want a part of the image to appear. And let's say I want 100 square piece from the top left part of the image. How can I get like that rectangle from the image? Well, the good thing is that this blit function also accepts a third parameter, and the third parameter is the area of the image that I wanna show on the screen. Now the area of the image is again a rectangle, just like bgrect is a rectangle. And in order to create a rectangle in Python, in Pygame, is defined by the x coordinate, the y coordinate, the width, and the height. So x and y are the coordinates inside of the image. So if I give it 0, 0, it will start from here. If for the width I give it 100 and height 100, it'll get 100 to here and 100 to here, and it will get this chunk from the image. So let's see it in action. So 0, 0, width will be 100, height will be 100, and when I run it, see, this is this chunk from the top left, from the top right, actually in the top left corner of the image. So let's say I don't want to start I want to get a center piece. So the image is 880, so let's say from 400, and this will be 300. take a square piece, so the height will be 100 and the width will be 100. And let's see what we get. So I get part of the elephant. So I think that this one, I'm getting this piece here from the elephant. So 400 will be 400 from the x and 300 from the y, and then take the width will be 100 and the height will be 100. So believe it or not, but this function that Pygame readily gives us is how we're gonna slice up the image into different pieces. So let's go ahead and do that. Now, right now we're gonna make it. I'll slice the image 3 by 3, so 3 rows by 3 columns, and then we're gonna make it dynamically, so you can slice it in more ways, in more pieces if you want to. So in order to slice the image, we need to have a couple of parameters. First of all, we need to have the rows. And again, this will be dynamically done when we finish the program. But just for the sake of explanation, I'm gonna hard code them right now. So columns will be 3. So if I have 3 rows and 3 columns, this means I'll have the total number of pieces will be 9. So number of cells will be equal to rows times columns. So this will be 9. Also, every cell will have a specified width and specified height. So in order to determine the width of each piece, we need to take into account the width of the program. The width of the program is 880. So take the width and divide it by the rows. So 880 divided by 3. So each piece will be this wide. I'll do the same for the height. Okay. Then I'm going to create an empty list of cells. Now, I need to make a loop that will loop 9 times, because in this case I need to have 9 pieces. Out of this image, I need to create 9 pieces. So I need to make 3 rows and 3 columns. And for each iteration, I want to take the rectangle. So I want to get the rectangle of this one, and so this will be 1, this will be 2, 3, 4, 5, 6, 7, 8, and 9. Let me just save it for reference. So the first time I go over the image, I need to have these coordinates, the x and the y. The width and the height of the image will always be the same. So every piece will be the same width and the same height, but the x and the y will be different. So the x of the first one will be 0. The x of the second one will be the width of this one. The x of the third image will be twice the width, because there are 2 pieces before it with the same width. So the x will be always for the third column will be twice the width. So the sixth image will be the same, twice the previous ones. The 9 will be twice the previous ones. The 2, the 5, and the 8, the x will be once the previous one. So the width of the previous one. And 1, 4, and 7, their x's will be always 0. So we need to think how we can do this so that the 1st, the 4th, and the 7th will always be 0. And actually we're going to be start counting from 0. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's actually a better way to represent the images. So here I'm going to create a for loop that will run 9 times. So I need to grab the x coordinate of each image. Now in order to grab the x coordinate, I need to grab the y and get the modulus from the rows. So the first time this thing runs, this will be 0. And actually let me write first times cell width. So the x of the first one will be 0, modulus 3 will be 0. So 0's times cell width will be 0. The second one will be 1. 1 modulus 3 will be 1. So 1 times cell width, this is the second one. The third one will be 2 modulus 3 is 2. So 2 times cell width will be 2. And then when I get to 4 modulus, actually the fourth one will be 3. So 3 modulus 3 will be 0. So this is where we start the second row. It will be 0 times cell width will be 0. So this the coordinate will be 3 here. 3 modulus 3 is 0. So the x will be 0 here. And the same thing is for 6. 6 modulus 3 is 0. So the x will be 0 here. Now we need to do the same thing with y, but y will move vertically. So with y, this will be 0, this will be 0, this will be 0. This will be the width, the cell width. This will be the cell width, this will be the cell width. This will be twice the cell width, twice the cell width, twice the cell width. So in order to do that, we're not going to take the modulus, we'll take the integer division of the columns times the cell height. So the first one here will be 0. 0 divided by 3 will be 0. Then comes 1. 1 divided by 0 is 0. I'm sorry, 1 divided by 3 is 0. Because this is integer division, it's not decimal. So the third one will be 2 divided by 3, again will be 0. And 0 times cell height, so this is the first row. So y here will be 0, y will be 0, y will be 0. Then it will be the cell height, y will be the cell height, twice the cell height, twice the cell height, twice the cell height. I hope this makes sense. If not, just think a little bit about it and you'll see that this is how it's done. And actually we're going to see it in a minute. So now that we have the x and the y coordinates, we need to create a rectangle with these dimensions. So I'm going to create a rectangle. Now this will accept x, y, width and height. So I have the x, I have the y. The width will be the cell width. The cell width for each pieces will be the same. The same thing applies for the cell height. It will be the same for each pieces. Now the last thing we want to do is we want to add this thing to the cells. Cells append. So cells is the list, and I want to append, but what I want to append, I don't want to append just the rectangle. I want to append it as a dictionary, because I want to pass some other parameters to that for each piece. So first I'm gonna add the rectangle. The second parameter I'm gonna add is the border. So each piece will have a border, and by default it will be white. Later, when we select images, we'll change the border to red. Now, the third parameter I want to add is the original position of this image. So right now they are in order. So we start from the first one, the second, the third. So I'll call it order, and I'll just pass I. So the first one will be 0, then 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and let me actually call this thing and see what's going on here. Print cells I. So when I run this one, we see 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 rectangles that we have created out from this image. The border is always the same, and this 0, 1, 2 is the first row, 3, 4, 5 the second row, 6, 7, 8 is the final row, and these are the original orders of the images. And we can see like the width and the height is always the same, but see the x and the y. So the first one is 0, 0, so it starts from here, from here. The second one is 293 by 0, so x is 293, 0, so y is 0. This is the first row, the y will always be 0. 587, 586, which is twice the width, because there are 2 widths before it. So 0 to 93, 856, 0 to 93, 586, 0 to 93, 586, and so forth. And the first row, the y will be 0, the second row will be 200, the third row will be 400. And that's natural because the image is 600. So it will be, 0, 200, 400. So 3 rows divided, 600 divided by 3 is 200 each. The height of each one of them will be 600. I mean 200. Okay, so this is all good and great, but I also want to add a random position to each image. So I don't want to show these images according to their order. I want to shuffle the order of these images. So inside of the cells list, I'm gonna add a random position to each one. So the position will determine where it will be shown. Whether it will be shown as first or second image or third image, not according to the order, but according to a random position. And there are a couple of ways to do that, but here I'm gonna add a position parameter, and I need to create a random position for each one of them. So the random position will be between 0 and 8, because from 0 till 8 are 9, and we have 9 pieces here. 3 by 3 are 9. So I need to create generate a random number between 0 and 9, but then I don't want this number to appear again. So once I generate a number between 0 and 8, I want to remove that number. So I'm going to create a list of random indexes, and I'm going to create, so the range will be from 0 to number of cells, and we need to make this into a list. And let me print it, rand indexes. Okay, let me just pass something here, doesn't matter. So here the random indexes, I have a list from 0 till 8 including. So I want to get a random index from here, and this will be the position where this rectangle will appear on the screen. So I can call it position or random position will be equal to random choice rand indexes. So this function will get a random element from this list, which is from 0 till 8 including. So it will generate a random index, and then I'm gonna assign it to random position. Now the problem is that if I run this one, let me actually remove these ones. If I run this one, you'll see the position here is 88005. 3 appears twice, so 0 appears twice. I don't want these things to appear because I don't want on the 8 position to print this and then this, because this will override it. I want these to be unique. They need to be actually unique. So when I generate the random position, which I get from this list, I want to remove this index from these indexes. So the random position that is generated, I want to remove it from this list. So rand indexes, remove rand position. So I'm gonna remove it, and let me run it again. And you see I have 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. So these are unique. The position is unique. So when I show them on the screen right now, you will see that this one will appear on the first position. This will appear next to it, and this will appear next to the second one. And then the third one will be on the second row, the first one on the second row. So let's actually go ahead and show them on the screen. Now again, here in the while loop, I need to create again a for loop. Let me see. For I, so the screen blit needs to accept the first parameter is the image. The second one is the rectangle of the image. So this is the parameter that I need to get. Okay. Actually, let me call it here cell. For cell in cells, background. Oh, wait a minute. The random position. Wait, what is that? So I don't want this one. I want actually the random position here. So the second parameter will be the rectangle which will be the position, and this is actually this one. So from the cell I need to get the rectangle. Now this is the position of the piece, but the third parameter will be what part of the image I want to show. Now for this one I'm going to create a image area, and I'm gonna need to create the image that I wanna, the part of the image that I wanna show. So I'll get the rect, the x. So from this rectangle I need to get the x, the y, and also the cell width and the cell height. So I'll pass this image area as the third parameter. Let me see what we have. Okay. The rectangle. Oh, sorry about that, guys. So this is not the rectangle, this is the position. So this is the random position that we add to each piece. For cell and cells, okay, let me get it as separate here. Oh, directed image position. Hold on for a second, guys. Let me check it out first. Okay, guys, so apparently here when we're getting the image area, we need to get the image area of the cell that has this random position and then get its rectangle. And using this loop doesn't work, so we need to use the enumeration loop because it gives us an index. So actually let me start from scratch. So for I val in, so we're doing it this way because we need the I for the index. Now we're gonna get the position, so we need to get this index here. And then we need to create a image area. So the image area will be this position. So if this is 1, we need to get the rect with the random position of 1. So we need to create a rectangle. So if the random position is 1, I'm gonna get from the cells the one that corresponds to the random position of 1, and I'll get its rectangle. And x, because each rectangle here has an x and a y. So I'll do the same for the y. And then the cell width and the cell height. And then I'm gonna blend it to the screen. So for the blend, we get the image, the rectangle of this image, which is and then what part of the image we wanna show on the screen. So this is the position of the image, and then what part of the screen, so the image area. And we see they appear, they're shuffled. So let me run it again to see if it's the same. It's different, and yes, it's different. So the elephant right now is here. Okay, now the last thing I want to do here is I want to add this border, because each image area has a border that by default is white. So pretty much I'm going to draw a rectangle around each image area. So the third parameter is the rectangle itself, so it's this one, and the fourth one is the thickness. And there we have it. We have white border around each image area. Well, now we need to add the clicking, so that when I click on an image, I select it, and if I click on a different image, I swap them. And let me just remove this printing statement. So in order to find out if I have selected an image, I need to I'm gonna add a variable image selected, and by default it will be none. Nothing is selected by default. So here in the event loop, where we're listening for all sorts of events, we're listening currently for the quit event. And let me just add the escape key. So if a user presses the escape key, the program also closes. So here we're listening for the quit event, here we're listening for a key down event. So every time I press a key on the keyboard, I will find out what kind of key is pressed. So here I'm listening for key presses, and if I press the escape key, I want to exit the loop and therefore exit the program. So it's the same as clicking the X button. So I'm gonna press the escape key and the program closes. Okay. Now, besides listening for the escape key, actually a little bit later we'll be using for the keys for choosing the difficulties. So we'll leave that later. Now, the other thing I want to listen is for the mouse button event. So when I click on mouse button, I need something to happen. For example, select an image, or if there is an image selected, I want to swap images. Now, when I click the mouse button, let me actually print it. So if I click the left mouse button, I get 1. If I click the right mouse button, I get 3 here. If I click the scroll wheel, I get 2. So 1, 2, 3. Left mouse button, scroll wheel, right mouse button. Now I don't want to listen for all these events. I just want to listen for the left mouse button. So if the event type is mouse button down and event button is 1, this is the left mouse button is clicked, then I want to do something here. Well, if the left mouse button is clicked, first of all I want to get the coordinates of the mouse button. Now this function Pygame mouse.getPos gives me the position of the mouse cursor. So let me show you. So if I click here in the very top left corner, I get 2, 3, 1, 2. So eventually this is 0, 0. And if I move on the x coordinate, the x is getting bigger and bigger. If I move the down, the y is getting bigger and bigger, and it will be here will be 880 by 600 almost. So this function gives me the x and the y coordinates of the mouse, and I'm gonna get them in a variable. Now, when I get them in a variable, I need to check if these coordinates collide with some of the images. So, in order to do that, I need to loop over this array of cells, this list of cells. So I need to go over the cells and check every time I click on mouse button if the mouse cursor is the coordinates of the mouse cursor are inside some of the cells. So I need to loop over all the cells. And let me get the rectangle of the cell, of the current cell. So this is the rectangle, and I'm also gonna get the order. This is the natural order of the cell. And let me actually print it. Print order. So when I run it, so I'm gonna click the first one. Okay. So the first, oh, it prints all of them. Yeah, it prints all of them because we need to get the individual cell. So in order to find out if the mouse collided with some of the cells, we use the so if the current rectangle collided with the mouse position, actually let me print the rect here, or the order. So this should be working right now. So this is 0, this is the first one. 1, 2, 3, 4, 5. Okay, this is working. So this is colliding with the corresponding. Now they don't, these coordinates, this is the original coordinates, so of course they will not coincide with the images here, because the images are shuffled. But a little bit later we'll be using this one to find out if the puzzle is solved. Now, if the mouse cursor collides with some of the image, we have pretty much two things. Is if the image is selected and if an image is not selected. So if an image is not selected, I need to set this current rectangle selected. Now if it's not selected, if not image selected, I need to set image selected to the current cell. So image selected will contain a dictionary of the selected image. It will contain a dictionary of the rectangle of the image, the border, its order, and the position, its random position. And also, I need to set the cell's border to red. If an image is not selected, I want to select it and save it inside of this variable, because when I click the next one I need to remember which one I selected before that, so in order to swap them. So I get the current selected image, save it as a reference, and then set its border to red. So let's try this one. So if I click this one, you will see the border is red. And because it's selected, nothing is working anymore. But let's see it again. So if I click this one, its border is selected. And now selected images is the selected image. The image selected is contains the image that I have already selected. Now, if an image is selected, we need to think about what we want to do in here. Now, if we get to the else, this means I'm clicking another image. But what happens if I click the same image? Like, I don't want to click the same image and there's nothing to swap, so I don't want to do nothing. So first of all, I'm gonna get the current image. So image selected is the previous selected image, and the current selected is the image I'm selecting right now. Now, I want to check that the current image and the image selected are two separate images. I don't want to do swapping if it's the same image. If I've selected an image and then I select it again, I don't want to I don't want to do anything. Actually, why am I calling it image selected? Let me actually change this to selected image. Selected image. And also here, selected image order. So if the current image order is different than the selected image order, means that these are different. Then I'm gonna swap the images. Swap images. Well, now let's think a little bit how we can swap the images. So the selected image and the current image will be in this format. Each of them will have a rectangle, border, its order, and its position. And naturally, what I want to do is I want to update the position. So I want pretty much to change their positions. When I click two images and they're different, I want to change the random position number. So let's say I choose 8 and 3. The one that has a position of 8, I want to have a position of 3. And the one that has a position of 3, I want it to have a position of 8. So I'm pretty much changing their positions. Because here, when I'm printing the images, I'm just printing them according to their random position. I take the rectangle of the random positions that I print. So I just need to change their positions. So in order to do that, now if I take the position of one and change it to the other, the original one will be lost. So I'm going to create a temp and let's say to selected image. Image position. Now when I override the selected image position, I will have it saved in the temp variable. Actually, so the cell, this selected image order, will return the order of the image, and I'll get its position. And inside of that position, I'll take the current image, the position of the current image, and I'll override the selected image position. And because I have it inside of the temp, for this one, it will be equal to the temp position. Oh, we immediately contain. Okay, this will be the number, so I don't need anything. Current image order. Okay. And the next thing I want to do, the selected image, remember the first image that we selected, its border was red. So I need to set it back to white. And then selected image is equal to none. I need to reset it to none so that the next time I select something else, I will run this code Now let's check it out. Okay, this is working. And as we see, the image is done, but nothing is happening because we didn't code the logic for the game over when the puzzle is solved. By the way, guys, if this thing seems kinda hard to understand, it's maybe a little bit harder, and probably it could be simplified, but pretty much cells is a list. So the first parameter is the number of the cell. So all cells have their order number. So I'm getting the order and I'm getting the position of the selected image. And then I overwrite it with the position of the current image. So by using this order, I can get the cells and then change their positions. If there are any if there's anything that you don't understand, guys, just write in the comments and I'll try to explain if things are not as clear as they should be. Anyway, so here when we are swapping images, besides the swap, we also need to change for game. We need to check for game over. Check if puzzle is solved. Now, in order to check if the puzzle is solved, we need to set another variable, is game over, and by default it will be false. Is game over, false. So when we start the game, we want this to be false, because later when we solve the puzzle, we'll be given the chance to play a game. So is game over, I'll set it equal to true. And then I'm going to check it. For cell in cells. And the best way to check if the game is over is to compare the order with the position. If the number of the order corresponds to the number of the position for all of the cells, this means the puzzle is solved. Because eventually when we're swapping these positions, the numbers, and as you remember, these are unique numbers that corresponds to these numbers, but while these are in order, these are random, but eventually when we're swapping the images, they will be equal as these ones. So if all the cells have their order equal to their position, the puzzle is solved. Now if for one of them this condition is not met, is game over will be equal to false. So if this condition is met, game over will be equal to false, and it will overwrite the game over variable. But if this condition is never met, this means that game over will remain true, and this means the puzzle is solved. And we can also add break here, or not, because we need to iterate over each of them. Okay, let's print game over. And here we have it. game over. Now it's printed okay, so we know that the game is over. Now what happens when the game is over? Here, so this is the event loop. Outside of the event loop, if the game is over, we want to show the solved image. So the whole image, we want to show it, because currently when we solve the puzzle, the borders around the separate images stay, and we want to remove them, and we want to show the whole image. So if not is game over, then I want to show the pieces. But if the game is over, else, this means game is over, I want to show the whole image. Okay, let's try it again. Okay, this is done. And there we have it. When the game is over, these things are, we get the whole image. And I can still click because we need to add this condition also here. So when we're clicking with the mouse, we want not only the mouse button to be down, not only the left mouse button to be down, but also and not is game over. Otherwise, if when we show the image, the mouse button will we can still work with the image. So this will make sure that the mouse button doesn't take effect when the game is over. Now when the game is over, I want to show a screen. I want to show do you want to play again? Do you want to play again? So in order to do that, we need to add some text. And let me maybe I can add here to the image. So I'm gonna have two types of texts: font title and I will use this font, the Hello Avocado font. So the title font will be the bigger one, and I'll have content font. Font content, let's call it. That will be 40. Okay, so I'll have two types of texts. And then that will say play again. Anti-aliasing will be true. And it will be white. Then I'll get a rectangle around this text, just like with the image. And I'll position it. Now all the text will position in the center, so this will be window height, it will be in the center, and I'll have continue text. it'll be the smaller text. So font content, and I'll get press space to press space. Like the message will be play again, press space. Anti-aliasing true, and again will be white. And let me actually let's just now I want to be on top of this. I'll move it down 50 pixels. And then here when we build the whole image, we're gonna build also the text. Okay, let's try it out. Play again. Okay, the mouse button is not working anymore because this is game over. And when I press the space, nothing happens because we haven't written the logic for the space bar key. So here in the event loop, here we're listening for event for Pygame key down, and we're listening for the escape key. Now, in order to listen for the space key, we're gonna get all the keys that I press, and if key space. So if this so here we're getting all the keys that are pressed currently, and if the key is space, this how each key has a key value, and this is for the space key. If the space key is pressed, I want to set this game over to false. That means the game is not over and I can start a new game. And also I want to set another variable here for the initial screen. So right now what we do is we hard-coded all this, but eventually we want this thing to be dynamic. And when we start the game, we want to have this initial screen that will show us the difficulty levels that we can choose from. So I'll call it show start screen. And at first it will be equal to true. When we start the game, we want it to be equal to true. And here, when we're pressing the space key, we also want to set it to true. Now, I guess we need to create the start screen. So for this one, let me just check if okay, no errors. Okay, so the start screen will contain, just sorry, this is the end screen, and this will be the start screen. So the start screen, there will be first of all there will be a title that will say puzzle game. And it will be crimson. Now I'll move it a little bit to the top because there will be some text under it. So under the title text, we'll have like an info message where we invite the users to choose their difficulty. So this will be font content. So it will be a little bit under the title text, and then we need free text for each difficulty: easy, medium, and hard. And we'll make them orange. And hard text. Okay. when we're inside of the game loop, we want to make sure that we start the game with the start screen. So by default, show start screen will be true, because when we start the game we want to show that screen. So let's see if it appears. If show start screen. Now if the start screen is showing, we wanna show this initial screen. Now first of all we're gonna fill the screen with black and then show all that text that we wrote. Now first we'll start with the title text. Then the choose text. Easy text. Medium text and hard one. Else all of this. So if it is the start screen, we want to show this thing. Else we want to show the images here. Okay, something is wrong with the title text. And this should be text. And here we have the initial screen. So when we start the game, we can choose our difficulty. Now currently, when I press E, M, H, nothing works. So we need to add this functionality. And here when we are pressing the keys, and here I'm just thinking about this. I don't want to check for the space key every time I press a key. I just want to check only if the game is over. So if it's game over, only then I want to check the space key. I don't want the computer to do more work than it should be, than it needs to. And the same thing is for the screen. If show start screen, this is a boolean variable. So I want to listen for E, M and H only when the start screen is showing. Otherwise I don't wanna make the computer run this code. So again I'm gonna get the keys. And then if keys, now this is for the when the E is pressed. And you might be thinking this is only for the lowercase e, but this thing works for lowercase and uppercase. So it doesn't matter whether you press lowercase or uppercase, it will work. So when I press this E key, I want to start the game. Now currently all that logic here is hard-coded, and I need to create a function that actually does this automatically depending on which key is pressed. So E is for easy mode. So I'll create a function called start game, and I'll pass free. So this is free by free. If keys Pygame key M, this is for medium, start game will be 4. so 4 by 4. The picture will be divided in 16 pieces. If keys Pygame key H start game 5, so this will be 5 by 5 for 25 pieces. This better elf. Okay. So I need to create a start game. So this functionality pretty much needs to be encapsulated inside of a function. Start game, and this will be the rows and the columns, like mode, for example. The mode. What mode is it? Now here we need to set up a few global variables, because this is a function and it needs to have access to these ones. And it needs to have access to these ones. I cannot put them all inside of the function, because rows, columns, number of cells, cell width, cell height, all these are actually, yeah, they're all used here inside of the program. So they cannot be local to the variable. So we'll have the global for the cells. So this is the the list of the images. Cell width, cell height, and also show the start screen. Now we'll see a little bit later why we need this thing also to be global. Actually, yeah. So rows is equal to mode, and same with the columns. Mode num cells is equal to rows times columns. Cell width, window width divided by rows. Cell height. And as you see, guys, we're doing the same thing here, but while here we hard-coded the stuff, these values, here this is according to the which key is pressed. So if I pass 3, 4 or 5, the cell width will depend according to the value that I pass for the mode. Now when I start the game, I want to reset the cells. I don't want it to contain the same cells. And then this thing, I want to run it here. And I also want to get these rand indexes. So yeah, we're generating the images. And lastly, what we're going to do in this function is the show start screen will be equal to false. So when I press the E, for example, I will run this function. It will generate the images and it will set show start screen to false. So then here, I'm not going to show the start screen. I'm going to show the screen with the sliced up images, the puzzle, the screen with the puzzle. And that's why I need this show start screen also as a global variable. And I believe this is, I can remove it. These ones I can set them to none. none. Actually, is that thing used somewhere besides the function? Oh yeah, it's not used. You actually don't need this thing. I use it only inside of the function, so cell width and cell height, they're used outside of it. Yeah, cell width. Here we use them. Okay, so let's just give them to none. Okay, let's run the game and see what's going on here. So E, press space. I'm gonna press the space bar, and I'm gonna press M, and it looks like everything is working. Let me just run it once again to pick the hard mode. Okay. Okay, so everything's working as expected, I believe. Well, that's all, guys. I hope you enjoyed this puzzle game. I hope you learned something new, and I'll see you in the next tutorial.